So today is going to be my last video in my series looking at integration. Previous videos we've looked at the basic principles and the basic techniques underlying integration. We've progressed on to looking at the harder techniques, and today we're going to be looking at integration as a method to allow you to work out the original equation of a curve. This video is not going to be compartmentalized like my previous videos. We're just going to go through two examples and then that's going to be the video in its entirety. So up until now we've been looking at something like this, dy by dx. So we've been given a first derivative, your gradient function, and we've been asked to just integrate this to find your original function. But you notice every time we've done this, so just applying my rules here, raise my power by 1, got x cubed there, divide this whole expression through by 3. Essentially I'd have 3 over 3, so that's fine. Same with this one, 3, raising my power on x here by 1. Essentially this 3 is the same as, if you like, 3x to 0. So raising my power by 1 here, I would be given 3x. And then the important part here, always remember your plus c. So this has been the case up until now. Each of our final answers when we are integrating first derivative like this has had plus c. Okay, so now we're going to look at a slight variation on this. We're going to be looking at the same first derivative here. It's still going to be 3x squared plus 3. And again, we want to work out the equation of the original curve, but now we've been given this additional bit of information here. So we're saying that our original curve passes through the coordinates 1, 8. So obviously here we've been given an x and y coordinate. And now that we've been given this, our equation for our original curve is not going to have that constant term in it. It's not going to have plus c. We can actually work out the value of that plus c. So in terms of your steps, it's going to be exactly the same. You're going to start off by integrating this. And this first step, remember we looked at this previously, which is x cubed plus 3x. And this one is going to have a plus c in because we haven't incorporated this information in yet. But now once we've done this, we can now substitute in our values, our x and our y values. So when x equals 1, comma, y equals 8 implies, I'm just going to substitute my x and my y values into here, and then we'll have an equation which we can solve, or rather we can just plug in our numbers and work out what we need to work out. So okay, so just replacing my y with 8 here, my x with 1 here, 1, 1. So this equals 1 plus 3 plus c. So here 8 equals 4 plus c. So your c is going to equal 4. Now we've got this. Last step, I'm going to come up here. So original equation is going to be y equals, so it's just going to be this, but I'm replacing my plus c with a value of c that we've worked out here, x cubed plus 3x plus 4. Okay, so we're going to have a look at another example now. If I have this, so you notice we've been given f dash of x rather than dy by dx. It still represents our first derivative, but now we're going to be working with our function notation rather than our y's and our x's. So again, we want to work out the equation of the original curve. It's going to pass through to 9. So just remember your steps. Step number 1, you need to integrate this, and then that expression on the right hand side will have your plus c in. And then step 2, you're going to use this information here, your x and your y coordinate, to work out the value of that plus c. So in terms of working out your original equation here, integrating this, a little bit of work required before we apply our laws of integration. So I'm just going to simply split up this fraction here. So notice the numerator has 2 terms in. I'm just going to express each of these 2 terms over the denominator. So notice I've got x squared here, x squared here, x squared there. Whatever this is going to be the denominator of both of these. Simplifying, the first one is equal to x, second one equals 2 lots of x to the minus 2. So if you're struggling to go from this step here to this step here, you do need to watch my video on integrating harder types of function. Links are up the top now. Now this is in the form that we can integrate it. So f of x, and remember this expression here is going to have our plus c in. So just applying our laws of integration here, essentially the power up here is a 1. So remember, laws of integration, raise my power by 1, divide by that new power. So this 1 now becomes a 2, divide by our new power. And then here, raise our power by 1, divide by our new power. And don't forget your plus c there. Just going to tidy up that second term now. So here I have dividing by minus 1. You don't really want to be dividing through by a negative. So I've got minus this negative term here. I could just do this. Positive 2x to the minus 1 plus c. Now coming over here, now we've found our expression with our constant term and with our plus c in. We actually want to work out the value of that constant term. How do I do that? I'm going to plug in these two numbers here. Right, so my 9 is going to go in place of my f of x on the left hand side, and then see this x coordinate here is just going to replace each of my x values here. So here I have x squared over 2, it's going to replace that 2, so it's 2 squared over 2 plus 2 lots of x to the minus 1 plus c. So I've got 4 on the top divided by 2 gives me 2 plus 2 lots of, now I've got 2 to the power of minus 1 here. What's that the same as? Or negative power means it's going to be 1 over. 1 over what is going to be whatever's in the brackets here raised to this power here. So in this case it's going to be raised to the power 1. If this was a 2, then it would be raised to the power 2 up there, and i.e. I'd have 1 over 4 in these brackets here. So I've got 2 plus 2 lots of a half, which is 1 plus c, which gives me 3 plus c. So here my c equals, subtract 3 from my 9 gives me 6. So my final equation is going to be, or original equation, is going to equal this, f of x, oh, I suppose that should probably be a colon, f of x equals x squared plus 2 plus 2x minus 1. So it's this thing here, and now I've worked out the value of my plus c, which was 6, so I can do plus 6 there. So really only one additional step, if you like, once you've worked out your original equation or the general form of your original equation here, and that is to work out the value of your constant term by plugging in the values given to you in the original question. And then once you've found out your plus c, you can just replace it into this equation here to give you the final form of the original equation, like that. Thanks very much for watching, and don't forget to subscribe for more tutoring videos. Remember that full notes and other resources are available on my tutoring website at idktuition.com. And if you'd like me to cover anything in particular, please leave me a message in the comments below or on Twitter at TomDavies32.